All right, so on this one, we're going to be still factoring a trinomial, but different signs here. So this is our standard form equation right here. There it is. Ax squared plus bx plus c. So we're specifically looking at these two. Okay, in this section, that b term will be positive, but the c will be negative. So we're looking at different signs. The process is still identical. Okay, always look for a GCF first. In example 1, I don't have one. So we're going to multiply the leading coefficient by the constant. But this time my constant is negative. So it's 12 times negative 5. That's negative 60. Factor pairs of negative 60. There's a bunch. All right. So they have to multiply to be negative 60, which means one of these sets of numbers has to be negative. Now I have to decide which one has to be negative. So that's when I look at the b term. So I'm looking at this 11. All right, so if my b term is positive, my little factor is negative. Okay, so if I make all these negative, and the reason the little factor has to be negative is because the bigger number the positive number has to outweigh the negative number to keep your b term positive. All right, so now I'm looking at each of these pairs, negative 1 and 60, negative 2 and 30, and so on, and I need to find a pair that adds to be positive 11. So that's your negative 4 and your 15. We still break it up, negative 4x, positive 15x, bring down that negative 5 and that 12x squared. All right, remember, this right here is still just 11x. It's just broken up into two pieces. Factor by grouping, first two terms and last two terms. GCF of the first group, GCF of the second group. Common binomial, and whatever is left. So we're doing the same thing on here. No GCF on this one. So multiply leading coefficient by the constant. One and 18, 2 and 9, and 3 and 6. B term is positive, positive 3, so my little factor is negative. Which pair adds together to be that positive 3? So that's the negative 3 and the 6. Break it up. Group. GCF of the first group. GCF of the second group. Common binomial factor, and whatever is left. Now remember, we discussed in the last one, these two versions are equivalent. They equal the same polynomial. If I were to graph these two, I would get the same picture. I would get the same graph. Hey, this one's standard, this one's factored, but they are. On number 3, no GCF. Looks like there should be, but this one kind of throws things off. Multiply leading coefficient by the constant. Factor pairs. I just start with 1 and I work my way down. So there's no trick to it. Let's see. I don't know how many times 3 goes into 72. Four does. Not 5. 6 does. 7 and 8. All right, I need a factor pair that adds together to be positive 1. Again, because the b is positive and the c is negative, my little factor is negative because the positive has to outweigh the negative here. Excuse me. So the factor pair that adds together to be 1 is negative 8 and positive 9. Group. GCF, that's 2x. GCF, that's 3. Common binomial, and whatever is left. All right. On example 4, we actually do have a GCF, so we need to take that out first, and then GCF is 2. All right, now for the moment, we're going to ignore that GCF. We're going to pretend like it doesn't exist, and we're going to look at the new leading coefficient, which is 6, and the new constant, which is -1, and we're going to multiply those two together. Factor pairs, little factor negative. Which factor pair adds together to be +1? Okay, so that's your -2 and your 3. Bring down your -1 and your 6x squared, ignoring the GCF for just a moment. Group, factor. Now remember, if there is no GCF, you can factor out a +1 or -1, in this case positive. Common binomial, and whatever is left. Now the GCF that I've been ignoring, you're going to bring it down.